Hi friends! In this video I show you how you can build like this dashboard to control your home automation based on Raspberry Pi. We try to control two LED, a servo motor, and sending a random value which represents temperature and humidity. We are going to use Adafruit IO Cloud to release this work. I prefer first to show you the demonstration part to know exactly what we are going to reach. This is the Raspberry Pi, and this is the terminal. I execute this Python code. So let's see the dashboard now. As we see here, I receive the temperature in real time in each 10 seconds. The temperature now is 10, and this is the humidity value. From here I can control room 1 and room 2. So let's see the result. 1, I toggle this button. As we see here, yellow, red turn on and the door open automatically. The servo motor represents the door. Let's turn the light off, as we see, and the door closed. When the wing of the motor turned right, the door opened, and left, door closed. Let's turn the red LED on, as we see here. Turn it off. Room 1 on, as you see, and this green indicator means the door opened, and when turn room 1 off, the door closed. The red color represents the door closed. Let's see the data which sent it from the Raspberry Pi. As we see, this is the data. So this is the last value of the humidity. Let's see, 16 and 6 temperature, and now 39 and 32, as you see here. Turn on, turn off. To achieve this work, you should follow these important steps. First, create an account in io.adafruit.com. This is the website. Get started for free. I was created an account. This is my account. Second, create the feeds. Feeds represent the objects which we are going to interact. In our case, we have 5 objects: door, humidity, temperature, room 1 and room 2. So let's create these feeds. To do that, go into feeds, view all. In my case, I created these feeds. So go into action, create a new feed, and give here a name, for example, a door. In a free accounts, give you just 5 feeds. You can't create more than 5 feeds. So this is all the feeds: door, humidity, room 1, room 2, and temperature. As I show you, just actions, create a new feeds, not a new groups, a new feeds, and give here a name. Try to give like this names. Here, room 1, there is no space between room and 1. So let's go into third step. Create a dashboard. So go into dashboard, view all, and actions, create new dashboard. Give here a name. In my case, I create home automation as a name dashboard. Fourth step, add the blocks into dashboard. Gauge to recuperate the temperature and humidity. Line chart to represent the temperature and humidity. A toggle to turn the LED on or off. And here, indicator to indicate the state of the door. So let's do these things. Type in home automation, and this is all the gauge. In your case, the dashboard will be empty. So to create a new block, type in plus button, create a new block. First, let's create a gauge. So this is the gauge. Here you should link the gauge with the feeds or the appropriate feed. I link it with the humidity. And next step, and give here a title, for example, temperature. And gauge mean value, here as we see 0, max value 100, as we see. Here gauge width 10 or 50 or 25. Gauge label, here for example Celsius. Low warning value 7 and high warning value 50 or 55. Here I put the temperature, the max value 50, and here 40. This is the test value. For example, if the value 20, the color will be blue. If the value out of the range 7 and 40, the color become yellow. Show icon, here you can add an icon. And create a new block. As we see the block here, we can edit dashboard layout and drag this block. So I delete it and I show you this gear button. So this is the gauge which I was created. As we see, temperature, gauge mean value and max value, and this is the icon, thermometer. You can add line charts as we see here and link this line chart with the temperature first. So this is the line chart. I try to edit the line chart to show you the options, temperature. Next, here I gave a name, temperature graph. Here show history, live, no history. The line began, draw when the data send it from the Raspberry. X axis label time, and here Y axis label temperature. Y axis minimum 1. I start from the 1 and the max value 50. So let's see, I start 1 and the max value 50. As we see here, 1 and max value 50. The same thing, we create the second gauge to interact with the humidity. So let's see the options. I link this gauge with the humidity, and I gave this name. Here low warning value 7 and high warning value 90, and the gauge label percent as we see here, and you can add an icon. From here you can add the toggle button. This is the toggle. I show you the options. I link this toggle button with room 1. So this is the option, room 1, block title, button on, and button off. As we see, you can change this name, for example, as we see. The same thing for the second toggle. I link this with the room 2. Here you should each block link with the feed. And this is the indicator. I show you how you can add an indicator. This is the indicator. I link this indicator with the door. Next step, here I gave a name, door, as we see, on color green and off color white. Here we have conditions. I show you how you can send a value into this indicator. For example, if I send 1, the value 1, the indicator will be on. And if I send instead of 1 any value or any another value, the indicator will be off. So this is the test value. For example, if I send 0, as we see the color red. So this is just the test value. This is not important. After that, here you can drag anything or change it. Cancel. So this is the dashboard. Here we have a secret Adafruit IO key. So this key will be important to the Python code. Five step, install the important Adafruit library into Raspberry Pi. So I type this command in the terminal. So first I am using VNC viewer. So this is my Raspberry Pi. The same thing for the Raspbian. This is the terminal. So first you should type this command to install the important library. I was installed, so I skip this step. 6. connect the component LED servo motor into GPIO of Raspberry Pi. So I show you the connection wires. So this is the GPIO. Here we have two LED and a servo motor. So the black line represents the ground, the blue line represents the signal, and the red line represents 5 volts into servo motor, because the servo motor has 3 pins. First pin into ground, second pin into signal, and the third pin into 5 volt. I link all the grounds of each object into one line. So in the code I try to use this GPIO. I use GPIO 26 and 19 and 13 and yes 13 and the 5 volt. We try to insert all this data into code. Download the code from the link and update your username and active key. You will find the code in the repository GitHub below the video. So this is the Python code. I try to explain this code step by step, don't worry. Here I wrote all the important data, how you can deal with this script, and I will add a link into explanation video. So this is the code. So first here I imported all the library to interact with the random value and to interact with the system, here to interact with the time, and here to interact with the GPU, general purpose input output, to deal with the pin of the Raspberry Pi. Here I delete this because I imported in the third line here, and don't forget to import this library. Here you should install the important library. You should write this command as I told you. GPIO.setMod BCM. So BCM means to interact with the pin. For example, if I want to interact with this pin, I wrote GPIO 26, not 35. If you want to use 35 and 37 and 35, you should here write board, not BCM. So BCM to interact with, for example, this pin GPIO 19. I create a function to interact with the servo motor. This function has two inputs, X and pin. X represents change duty cycle. So here you should know exactly how the servo motor works, but don't worry. This is the common code. Here the important thing, the pin, and if the X equals 2.5, door opened, else or other value than 2.5, door closed. This function to interact with the light has two inputs, pin and status. I use status because the dashboard send me a data in a string type on or off. If I receive on, I put on the LED as we see here 1, or I can write true. If I receive other value than on, I turn off the light. This function return a random value between min val and max val. We try to use this function to send a random temperature and humidity value. So this is Adafruit IOK. So here you should set your Adafruit key and Adafruit username as I show you. To get your key, click in this key button, and this is the data. Copy the username and the active key. MQTT protocol, message queue telemetry transfer. MQTT protocol interacts with objects as a subscriber or a publisher. A subscriber if you want to receive the data from the Adafruit cloud. As we see here, we are going to receive the data which come from room 1 and room 2. Room 1 and room 2, this is a feed, and we are going to interact with this feed with the toggle button. If I turn on, I send on character, and if I type off, I send off character. So this method called one disconnected function will be called when the client disconnects. So this function will be called when a subscribed feed has a new value. So here, as I told you, I receive a data which come from feed room 1. Print room 1 is turned, and the payload, this value get two possibility, on or off. So this, I call this function light 26. This represents the pin, GPIO pin, GPIO 26, and the payload take on or off. If I receive on, I turn the LED on. If I receive another value, I turn the LED off. If payload equal on, door control, here I return the wing of the servo motor left and the pin 13. This is the pin 13. And I send a data, a publish, clients.publish. We use publish to send the data into dashboard. Into feed door, I send number 1 to turn this indicator in green color. If I receive 1, I turn the indicator into green. So this is the code here. Clients.publish the feed door and number 1. Else, if the payload equals off, I do this action, door control, I close the door and the pin 13, and I send 0 value. Zero red color. Here if feed ID equals room 2, to interact with the second LED, light 19, the pin 19, and here the payload takes on or off value, and the pin 19. Let's see this pin and the image. This is the pin GPIO 19. So this is the common code. Don't touch in this part from the Adafruit cloud. So this function executes in the background. Client.connect. So here we have a time value 10 seconds. Here while true, an infinite loop. Temp receive a random value between 0 and 50, and we try to send the temperature value, this line, just to write it in the terminal. Client.publish, I was sent a temperature data, temperature, and the temp, which take a random value, and the same thing for the humidity. So this is represents the first parameters. This is the first parameters, and the second parameters represent the unit. The same thing here, and client.publish humidity and time.sleep. In each 10 seconds I do this loop. So this two object, temperature and humidity, linked into gauge in the dashboard and into chart line to see the graph. I execute the code again to see the output. This is the temperature value and humidity. Let's see the dashboard, as we see, and this is the update. Let's toggle the button. As we see, room 1 is turned on and door opened. Room 1 is turned off and door closed. I wish this video will be helpful for you, and we will meet in another video.